Find the early finish of activity E. In this problem, we know the early start of the project is 1, and we are provided a project summary table which lists the 5 activities of the project, which are excavation, formwork, adding rebar, inspection, and pouring concrete. These activities are labeled A, B, C, D, and E, respectively. The given table includes a column identifying the duration of time it takes for each activity to be completed. The last column in the table identifies the predecessor activity, which is other activities which must be completed before that activity can begin. For example, formwork is activity B, which has a predecessor of activity A. Therefore, before formwork can begin, excavation must be completed. In the same way, rebar cannot be added until the formwork is complete, because activity B is listed as a predecessor of activity C, and letter B refers to formwork. Certain activities may have no predecessors, which is the case for activity A, excavation. Also, certain activities may have multiple predecessor activities. If we look at our first 2 activities, we can say that activity A is a predecessor of activity B. We can also say that activity B is a successor of activity A. The terms predecessor and successor are commonly used in construction scheduling problems. Back to the problem, we notice activity A cannot start until activity D is completed. Activity D cannot start until activity C is completed, which cannot start until activity B is completed, which cannot start until activity A is completed. Next, we can visualize the progress of construction by using a network diagram, which is composed of boxes and arrows. A more detailed version of this same diagram is shown here and lists the names of each activity in the top of the box. As before, excavation refers to activity A, formwork refers to activity B, and so on. The values in each of the 6 cells in each activity have a particular meaning. If we focus in on activity A, excavation, and we refer to our activity box template for network diagram problems, we can define the meaning of each value in the box, where ES refers to the early start of an activity. D refers to the duration it takes for an activity to be completed. EF refers to the early finish of the activity. LS refers to the late start of the activity. F refers to the float of the activity, and LF refers to the late finish of the activity. As a note, some texts use the terms earliest and latest instead of early and late, so just know these terms share the same meaning. The values of the 6 variables in the activity box refer to a time. Looking back at activity A, which refers to the activity of excavation, we added a subscript A to each of the 6 variables. Similarly, we can add the same variables to all 5 activity boxes and include the unique activity ID letter as a subscript for activities B, C, D, and E as well. In this problem, we're asked to find the early finish of activity E. We identify this variable in the top right corner of activity box E. From the problem statement, we also know the early start equals 1. Since activity A, excavation, is the first activity in the network diagram, we'll substitute in ESA equal to 1. As it turns out, we will not need the late start, the late finish, or the float to solve this problem, but we'll keep these variables in the box diagram structure. Next, we'll populate the time duration it takes for each activity to be completed based on the data provided in the problem statement in the duration column. Activity A has a duration of 1. Therefore, we'll plug in 1 for variable dA. Similarly, we'll substitute in 1, 2, 1, and 1 for the duration of activities B, C, D, and E, respectively. Next, we'll calculate the early finish of activity A, EFA. The early finish of an activity equals the early start plus the activity duration. For the early finish of activity A, we'll plug in 1 for the early start and 1 for the activity duration, and the early finish of activity A equals 2. Since activity A is the only predecessor of activity B, then the early start of activity B equals the early finish of activity A, which equals 2. Similar to activity A, we can compute the early finish of activity B by adding the early start of activity B to the time duration required to complete activity B. The early finish of activity B equals 3. Since activity B is the only predecessor of activity C, the early start of activity C also equals 3, which makes the early finish of activity C equal to 5. If we continue this process through for activities D and E, the early finish of activity D is 6, and the early finish of activity E equals 7, which is the value we were asked to determine. When reviewing the possible solutions, the answer is D.